Hydrogen ions and acidity. Water self-ionizes, which means a molecule of water will break apart into H plus and OH minus. In pure water, H plus and OH minus are equal, 10 to the negative 7th. So the amount of products is very small. Another way to write the self-ionization of water looks like this. I can take two water molecules, break those apart into H3O, which is called hydronium, and OH. Now hydronium and H plus mean the same thing. Hydronium is nothing more than H plus added to water. One of the four equations that we will use quite frequently is called the ion product constant for water, Kw, and that's equal to H plus times OH, and the number is always 10 to the negative 14th. I can tell whether a solution will be acidic or basic by comparing H plus to OH. Acidic solutions have a greater amount of H plus. Basic solutions have a greater amount of hydroxide. Let's look at an example. I want to find H plus if I know what hydroxide is. Well, I know H plus times OH is always 1 times 10 to the negative 14th. So plug in my hydroxide, which is 10 negative 11th. Then we can divide to get H plus. In this case, 10 to the negative 3rd molar. Is the solution acidic or basic? Well, H plus 10 to the negative 3 compared to OH minus, which is 10 to the negative 11th, well, H plus is greater, and so that means it's acidic. And we know soft drinks are pretty acidic. One of the equations then that we're going to use quite frequently, H plus times OH is 10 to the negative 14th. Here are the other three. pH equals negative log of H plus, POH, negative log of OH, and then pH plus POH equals 14. The best way to tell whether a solution is acidic, basic, or neutral, look at the pH scale. This is the most commonly used scale. If the pH is less than 7, it's acidic. If the pH is greater than 7, it's basic. pH goes anywhere from 0 up to 14. It's always positive from 0 to 14. There are rules with significant figures in pH, but we haven't really been using significant figures too much, so I'm not going to worry about this rule. Let's look at the examples. We've got four equations to choose from. Example 1, what is the pH if I know H plus? Well, pH equals negative log of H plus, so I can plug in my H plus concentration, which is 0.045. On your calculator, find the log function. You don't have to know what a log is, you just have to know how to plug it into your calculator. So take the log of 0.045, make it negative, and you should get a pH. Remember, it has to be positive from 0 to 14 of 1.35. Very acidic. Closer to 0, the more acidic you get. Second, calculate the H plus if I know pH. Same equation will work. pH 12.83. Negative log of H plus, I'm going to bring the negative to the other side. To get rid of the log in front of H plus, I have to take what's known as the antilog. So to get H plus, take the antilog, which is the button right above the log key on your calculator. It should say 10 to the x. So we're going to take 10 to the negative 12.83. We're going to take the antilog of negative 12.83 to get H plus. So make sure you can find that function, and you'll get a value for H plus of 1.5, 10 to the negative 13th molar. The hardest part is plugging these into your calculator to get the correct answer. Let's look at a couple more. I know OH. I want to find pH. Couple ways to do this problem. I'm going to find the pOH by taking the negative log of OH. So take the negative log of 4.310 to the negative 5. This is just the regular log, not the anti-log. And you should get a value for pOH of 4.37. Well, I don't want the pOH, I want the pH. But I know pH plus pOH equals 14. So pH plus 4.37 equals 14. That means my pH, when I subtract from 14, 9.63. I had to use two equations to get to the answer in this problem. Okay, last one. pOH is 4.5. What is H plus? Couple different ways to do this. But pH plus 4.5 equals 14. This is one way. So pH is 9.5. Once I get the pH, I know that's the negative log of H plus. So 9.5 equals negative log of H plus. In order to get H plus, I have to take the anti-log of negative 9.5. So take anti-log of negative 9.5, and you should get on your calculator 3.2 10 to the negative 10th molar. So some of these problems have more than one way to get to the correct answer, but again, the hardest part for most is just putting it into your calculator to get the correct answer. So how do you measure pH? Well, you can use an acid-base indicator, which is an acid or base that undergoes dissociation in a known pH range, and the acid and base forms have different colors in solution. And so the acid form will dominate at the low pH, that's got one color, and your base form will dominate at the high pH, and that's got a different color. And as they change colors, you will be able to tell whether it's acidic or basic. One of the most common ones is phenolphthalein. It changes from colorless to pink as the acidity changes. pH meters also measure pH, and these will give you a digital readout of the pH. They're usually accurate to about 0.01 pH units. So if you want to get close to the actual pH, pH meters are the way to go.